So this is week 8, day 3 we're looking at. And the first calculation that we are going to explore is 3 2/3 take away 5/6. Now, just going to remind you to have a little look at the fractions first of all. Have a look at the fraction and have a look at the mixed number. Think about what we did yesterday. So we looked at our fraction yesterday and we said, right, was it bigger, was it greater or less than the fraction that we had with our whole number? So is 5/6 greater or smaller than 2/3? So if you can't see straight away, if you're not too sure if that's greater or which is greater and which is smaller, we're going to find a common denominator. We're going to find a common denominator. So what we can do is we can have a little look here, just at the fraction, and we're going to turn our thirds into sixths. Okay, so we can have this as 3, and it's going to be sixths, and pull this one down, and we're in 5/6. Okay, lovely. So I'm going to put my times 2 there, and I'm going to put my times 2 there, which gives me 3 and 4/6, and I need to subtract 5/6. So stage 1 is to find that common denominator, in which, in this case, denominator. In this case, it's 6. And then we can look to see if we can subtract it straight away. Can we subtract without going into the previous whole number? And we can't, because 5/6 is greater than the 4/6. So we need to do another stage. No, we need to go to stage 3. So if it was a yes, you could have subtracted. No. So what we need to do now is we need to turn this here into an improper fraction. We need to turn this into an improper fraction. So we've got 3 and 4/6. So we need to find our wholes. So let me have a little look. Which represents my whole? That's my whole. So I'm going to show you using the counters, using the rods, how we do that. There's my 3 wholes. And there's my 4 trusty sixths. There's my 4/6. Just double check. If I add 2 more in, does it equal the whole? Yes, it does. Good. Okay, so remember, to turn the mixed number into an improper fraction, we need to figure out how many sixths there are in 3 wholes. Okay, so I know that there's 6 sixths in this whole, in this one whole. I therefore know that there's another 6 sixths in this whole, and then there's another 6 sixths in this whole. So I know that 3 times 6, which are my 6 sixths, is going to give me 18 sixths. But I'm not finished. That's not my answer. It's not 18 sixths, because I have to add in these extra 4 sixths. So it's 18 sixths, 19 sixths, 20 sixths, 21 sixths, 22 sixths. So my improper fraction is 22 sixths. Now, if you were doing that without using the concrete or without using the pictorial, what you need to think is how many sixths make one whole. So you need to do 6 once, 6 lots twice, 6 lots 3 times, which gets you to 18. Then you add the 4 that you've got, which gets you to 22. And I can pull down my 5, which is what we're going to subtract, my 5/6. That doesn't need to change. So I can work out now 22 sixths, take away 5/6, and number 4, subtract fraction from improper fraction, and that's going to give me 5 from 22 is going to give me 17 sixths. 17 sixths is your answer. And if you want to leave that as a mixed number, you would turn your improper fraction into a mixed number. So I'm going to put this as an option. It's a good habit to get into because we'll be doing this in year 6. Leave as a mixed number. So you've got to think, okay, 17 sixths. How many sixths make 1 whole? 6. How many sixths make 2 wholes? 12. How many sixths make 3 wholes? 18. Now I don't have 18, so I know my answer is going to be 2, which is 12 sixths. And then how many extra sixths have I got? I've got 5 sixths. So my answer is 17 sixths, which is equal to 2 and 5 sixths. Okay, fab. Right, next question. Add 3 and a half to 4 and 7 tenths. Add 3 and a half to 4 and 7 tenths. Okay, so we can turn halves into tenths, but in this case, we can't turn these tenths into half because we have an odd numerator. So I'm going to pull this one down. I'm going to leave this as 4 and 7 tenths. I'm going to leave that as 3 because I'm just looking at converting my fraction into tenths. And I know that I have to multiply my denominator by 5 because that is going to give me tenths. And I know that I can multiply my numerator by 5 to keep the value the same. So I've got 3 and 5 tenths, add 4 and 7 tenths. So what we can do here is we can add our 2 whole numbers. So we've got 3 add 4 equals 7. And then, like I said before, if it helps, cross them off. So now I just need to do 5 tenths add 7 tenths. And you see how we've already got a common denominator because we did that first. That was the first step, yeah. We know we've got 12 tenths. Now we can't leave it as 7 and 12 tenths. Can't do that. Why not? Because it's an improper fraction within a mixed number, and we can't leave it like this. We have to turn it into a mixed number properly. So this improper fraction here needs to become a mixed number. So we know that 10 tenths is 1 whole, and then we've got these 2 tenths left over, so it's 1 and 2 tenths. Add that to the 7. 7 add 1 and 2 tenths gives us 8 and 2 tenths. So 3 and a half, add 4 and 7 tenths gives us 8 and 2 tenths. Okay, lovely. Next question. Similar to one we had yesterday, actually. Which is greater? 4/5 or 4 tenths? And again, look at the fractions. Don't just jump into a method. Actually look at it and see what you can see. Say what you see, isn't it? It's like catchphrase. What do you notice? Okay, so the denominators are different, but the numerators are the same. So we just need to focus on those denominators because we know we've got the same amount of each part, as it were. So which is the greater value? Which has the greater value? Well, we know that if something's split into 5 equal parts and something's split into 10 equal parts, the 10 equal parts, one of those 10 equal parts would be a smaller part than one of those 5 equal parts. Let's just have a look at that. Because in the regular number system, in whole numbers, we know that 10 is greater than 5, and that's a misconception that you can have. A lot of people think that 4 tenths is greater than 4/5, because in positive numbers, 10 is a greater number than 5. But let's see, because it doesn't really work when it comes to fractions. I'll show you how. Okay, so they're my fifths. And they're my tenths. So you can see that 1/10 is actually half of a fifth. It's a smaller part. So those 4/10 take up this much space here. That's those parts. Whereas my 4/5 is that large part there. And sometimes it can help to do that. It can help to draw it out and just compare it. So we know that 4/5 is greater than 4/10. 4/10 is less than 4/5. Okay. Oh, we've got another sequence now. Last question. We've got a sequence of numbers. So we're going to start with 350, 370, 390, and then what's next? We don't know. Okay. What's the same and what's different? What do we need to look at for this sequence? Okay. We know that these are all in the 300s. We also know that this is 50, that's 70, and that's 90. So what's the difference between the values that are next to each other? Well, it has a difference of 20. We've added 20 onto 50 to get to 70. And we've done the same here. We've added on 20 to 70 to get 90. So we know the pattern is adding 20. There is a difference of 20. So 390, partition that 20 out. Add 10 and then add 10 if that helps. So add 10 to 390 and that gets you to 400. And add another 10 to make you 20, which gets you to 410. Well done. Good stuff.